Welcome to today's lesson. This is Blessed Elvis. So in today's lecture, we are going to discuss how we can simplify and solve the given functions of logarithms. So in the previous video, in part 1, we had discussed some of the rules that we use when it comes to logarithm functions. So make sure that you watch that video and then link it to this one, because everything we are going to do here is linked from the previous video. So make sure that you like the video and also subscribe to the channel so that we keep updating more information of the same kind. So let's do that. So we are going to start with examples. So let's say we have log 4, log base 4 9, and then we also have log, let's say 4 21, and then let's say minus log 4 7. So how do you think we can simplify such a logarithm function? So as we can see, log base 4 is common to all the sides. So let's factorize it. So we are going to have that. And then here we are going to have what? 9. Now, according to the rules, when you are adding the logs, it simply means you are multiplying the values. So in this case, we are going to multiply. So remember, we have removed this. So here we are remaining with what? 21. Then, when you are subtracting the logs, it means you are dividing the values. So make sure that you understand this concept. All these are discussed in the previous video. So in this case then, we are going to have log 4, and then in this case we are going to begin with multiplication, or rather division according to Bodmer's rule. So we are going to divide 7 into 21, which of course is 3. Then 3 multiplied by 9, it's what? It's 27. Okay, so in this case we can simplify this further, because we know 27 is a perfect cube root. So in this case we are going to have log base 4, and then 27 is the same as 3 raised to power 3, because 3 raised to power 3, it's what? It's 27. So let's simplify this further. We have to simplify in such a way that we are not remained questioned. So when we have the power, according to the rules discussed in the part 1 of the same, we had said when you have the power, you write it in front of the log. So in this case, we're going to have 3 in front, and then have log base 4, and then 3 here. So this is the simplification of this logarithm function that we were given. So let's look at more examples. Let's say we have been given log, let's say log a, and then we have 8 over 27. So how can we simplify this? So according to logarithmic rules, it means that here you are subtracting. So in this case, we're going to have log a of 8 minus log a of 27. So this 8 here, we know it can be written as a 2 power 3, and then minus here log a, this 27 here can be written as 3 power 3. So these powers can come in front. So this one here will come to this front here. So we're going to have 3 log a of 2 minus this 3 as well will come to the front. We're going to have 3 log a of what? Of 3. So this is how basically we simplify the given functions. Now let's say you have been given certain values. Let's say you have been given to say if log 5 of 2 equals to, let's say, 0.431, and also let's say you have been given log base 5 of 3 equals to 0.683. There is a point here, point. So how can you apply this when you have been given different logs? Let's say the first log, let's say you have been asked to find the value of log 5 of 6. So here, for you to simplify this, you have to make this in such a way that you will have this log here and also this log here, so that you can replace it with these values. So there is a point here. So in this case then, let's try to simplify this. So we know that 6 is the same as 3 multiplied by what? Multiplied by 2. So in this case, we are going to have log 5, and then when you are multiplying according to the rules, it means that we are what? We are adding. So it's log base 5 of 3 plus log base 5 of 2. Okay, so in this case then, let's replace with the values. So log 5 of 3, you have been given as what? 0.683, and then let's add log of 2 has been given as 0.431. So when we add these two values, we are going to have what? We are going to have 1.114. So this is the answer. So when you have been given such logs, you simply have to simplify the given expression in a simplified way, and then you replace with the logs that you have been given. So let's look at more examples. Let's say this time you have been given of the same, you have been given log 5 1.5. So you have to simplify this. So for us to know the value of this, let's write it in fraction form. So we have log 5, and then this one here is gonna be, it's the same as 3 over 2, because 3 over 2 is the same as 1.5. So in this case, when we are dividing according to the rules, it means that we are subtracting the logs. So it's gonna be log of 3 minus log of 2. Now we know that log of 3 is given as 0.683 minus log of 2 has been given as 0.431. So when we subtract the two values, we are going to have 0.525. So this is the answer for such kind of an expression. So let's look at one last example on the same. Let's say this time we have been given, so let's say you have this value. How can you simplify it in such a way that you replace with these values? So let's say you have log 5 8. So we know that 8 is the same as 2 raised to power 3. Okay, so in this case, let's take this power to the front here according to the rules. So we're gonna have log, rather it's gonna be 3 log 5 of 2. Okay, and we know log 5 of 2 is what? 0.431. And then when we multiply this, we are going to have what? 1.293. So this is the answer for this kind of an expression here. So this is basically how we replace the given values into the expression. That's how it goes. Okay, so let's go into multiplying, or rather solving given different values of logarithm functions. So let's say, for example, you have been given 2 log 3 of x equals to, let's say, log 3, let's say x plus 6. How can we simplify such, or rather solve the value of x? So you have been asked to solve the value of x. So you firstly have to simplify this expression. So we know that this value here is the same as the power of x. So let's write that. So we have log 3 of x, and then you have power 2 equals to log 3 and then x plus 6. So since log 3 is common to both sides here and there, we can simply divide log 3 to both sides, log 3, so that we can cancel this and that, this and that. Then remain with x squared equals to x plus 6. So what we have there, down there, is the quadratic equation. So go ahead and find the values of x using the given quadratic equation. So here we have squared. So in this case, taking these values to the left side, we're going to have x squared minus x, and then we're going to have minus 6. Here we are going to remain with 0. So let's find the product sum and the factor. So using the factorization method, you can find the values of x. So you can use whatever value is applicable for you. So in this video, we are going to use the factorization method. So we know the product is the coefficient of x squared, which is 1 here, multiplied by the constant value, which is negative 6. So 1 multiplied by negative 6, it's negative 6. And then the sum, we only get the value of x coefficient. So here, there is only what? 1. So in this case then, our sum value is negative 1. So which numbers can we multiply for us to have negative 6 and then add the same values to have negative 1? Okay, so it's negative 3 multiplied by 2. So negative 3 multiplied by 2, it's negative 6. Then negative 3 added to 2, it's negative 1. So let's replace these values on the x coefficient. Or rather, sorry for the disturbance. My apologies. So we're going to replace where there is this coefficient here with the factors that we have found. So it's going to be x squared, and then we're going to replace with 3. So you add the coefficient that is, rather the variable that is present in the expression. In this case, it's x. So you're going to add x. So it's going to be x, then plus 2x, then minus 6 equals to what? Equals to 0. So in this case, x here and there is common. If you want, you can categorize them into two terms. So here x is common, and when we move x here, we're going to remain with 1x, minus when we move x here, we're going to remain with what? With 3, and then plus. We know that 2 can go into 6, so hence it's also common. So when we move 2 here, we're going to remain with what? X, and then 2 into 6, it's what? It's 3. So we have 3 here equals to what? Equals to 0. So let's rub some of the information that we don't need here, because it's going to be a lot since we have already used them. So in this case then, as we can see, this and this are the same. So you only get one value here, that is x minus 3, and then you get the values that are outside the brackets. So that is x plus 2, okay, then all of these equals to what? Equals to 0. So let's solve for x. So we are going to equate each term to 0. So in this case, we're going to have x minus 3 equals to 0, and also x plus 2 equals to 0. So let's wrap the top part here. Okay, so in this case then, we're gonna have x, when this negative 3 comes to the right side, it's gonna be positive. So it's gonna be 0 plus 3, and then when this positive 2 here comes to the right side, it's gonna be negative. So we're gonna have that. So x in this case is gonna be equal to 0 plus 3, it's 3, and then x is equal to 0 minus 2, it's negative 2. So these are the values of x. So this is how basically we simplify the expression and find the values of x. So let's look at another example. Let's say we have log 5, and then let's say we have x squared minus 3x plus 2. Let's say here we have minus log 5, and then we have x minus 1. This equal to what? Let's say it's equal to 2. So in this case, as we can see, log 5 is common. So in this case, we're going to factor it out. We are going to factorize it. And then when we factorize it, when you are subtracting here, by now we know it means you are dividing these terms here. So in this case, since we are subtracting here, it means we are going to divide. So we are going to divide x squared minus 3x plus 2 over this term here, that is x minus 1 equals to what? Equals to 2. Now, by now, we know and understand how we can express this into exponential form. So after you are done with this, you have to express it into exponential form. So how can we express this into exponential form? So in this case, this is just going to be the way it is, according to the rules discussed in part 1 of the video, of the same topic rather. So this is gonna be, so in this case, this is gonna be here, and 2 here is gonna be the power. So we're gonna have that. So let's simplify this further. So we have x squared minus 3x, then plus what? Plus 2 over x minus 1 equals 2. Now we know that 5 squared is what? Is 25. So let's wrap the top part here so that we can use it for further simplification of the expression that we have now. So in this case then, since we have this, okay, let me just even wrap this. Okay, since we have this, so we can cross multiply here, this and that. So we're gonna multiply 1 multiplied by all of the numerator here, it's just x squared minus 3x plus 2 equals to 25 multiplied by x here, it's what? It's 25x. Then 25 multiplied by negative 1 here, it's negative 25. Okay, so let's take these values to the left side. So we're going to have x squared minus 3x. When this positive 25x comes to the left side, it's going to be negative 25x. Then here we have positive 2. When this negative 25 comes to the left side, it's going to be positive 25. And then here we're going to remain with what? With 0. So let's simplify this. So we have x squared minus negative 3x added to negative 25x, it's going to be negative 28x. Then 2 added to 25, it's what? It's 27. So we're going to have 27 equals to 0. So in this case, let's now simplify this further. So we know that what we have there is the quadratic equation. So by now, I'm sure you know how to solve the quadratic equations. So make sure that you try this one. So let's find the product, the sum, and the factors. So we know the product is the coefficient of x squared multiplied by the constant value, which is 27. So the coefficient of x squared is simply 1 because there is no value here. So it simply means there is 1 here. So 1 multiplied by 27, we're going to have 27. And then the sum is simply the value of the x coefficient, which is negative 28. Then the factors are the values you can multiply for you to have the product, that is 27, and add the same values for you to have the sum, that is negative 28. So which values can we multiply for us to have 27 and then add them to have negative 28? Okay, it's negative 1 and negative 27. Because negative 1 multiplied by negative 27, it's positive 27. The negative 1 added to negative 27, it's negative 28. So these are the values we are going to replace where there is the coefficient of x. So we're going to have x squared minus, here since we have only 1, it means there is a variable of x. So we're going to have 1. Here we can't write 1x. That's why we've just written x, because even if we write x, it simply means there is a coefficient of 1 here. Then minus 27, we are going to add the coefficient, or rather the variable that's present in the expression, that is x. So it's going to be negative 27x. Then plus 27 here equals to 0. So in this case, let's categorize them into 2. So we have that. So in this case then, we're going to have x is common here and there. So we're going to have x outside the brackets. And then when we move 1x here, we're going to have x. Then x into x, we know it's 1. So we are going to have 1 here. And then minus 27 is common here and there. So it's going to be out here. So 27. And then here we're going to remain with x. And then negative multiplied by positive, it's negative. So we're going to have negative. Then 27 into 27 here, it's 1. So we're going to have 1 there equals to 0. So let me just write on top here. So here we know that this and this are common terms because they are the same. So we're just going to write only one term here, that is x minus 1. And then we write the values that are outside the brackets, that is x and negative 27. So it's x minus 27. All of these terms equals to 0. So let me just wrap the information that we no longer need here. So hopefully that you are following step by step. Make sure that you do that. Okay, don't forget to follow up. And whenever you don't understand, make sure that you rewind the video and then rewatch, because this is going to be very important for you. So x minus 1 and x minus 27, all these terms will be equated to 0. So we're going to equate x minus 1 to 0 and also x minus 27 to 0. So in this case then, when we take negative 1 to the right side, it's going to be x equals to 0. It's going to become positive. And when we take 27 as well to the right side, it's going to be positive 27. Then 0 added to 1, it's 1. Then x here it's going to equal to 0 plus 27, it's 27. So these are the values of x. So this is basically how we solve the given different logarithm functions. You first simplify them and then solve for the variable that is present. So this is all for this video. Thanks once again guys for staying this far. Please like, subscribe, share and turn on the notification button so that you are updated whenever I upload a new video. Stay blessed.